In this video, we'll look at integration by parts. Now, we have already seen that if we were to differentiate a product, we have a product rule, and we end up with U-V plus UV dash. So we now know that if we were to integrate this term here, we end up back at the original function. So if I integrate U dash V plus UV dash, I end up with the UV function. So if we were to use one of the rules of integration where we can actually split this pair of terms up, the sum of those two terms can be expressed as two separate integrals. And now if we rearrange, we can make this expression here the subject, and we're left with the integral of u times v dash integrated with respect to x equals the product of u and v minus the integral of u dash times by v with respect to x. So this technique can be used if we have a product of terms here. Substitution can be used if one is the derivative of the other, but sometimes we don't get that. So this technique can be used. So first example, now a note at the top here, which one do you let u equal? Well, often you'll choose u as the term that becomes simpler when you differentiate. So in this case here, given these two terms here, if I were to let u equal x, if I differentiate that, I get 1, which is simpler. If I let u equal e to the minus x, then if I differentiate that, I get minus e to the minus x, which is not any simpler. So we're going to let u equal x in this case. So I've got my u and my v dash. So now let's work out what the derivative of u is. So u dash is 1. And if I were to integrate v dash to go back to get v, I end up with, now e functions don't change, but I divide by the derivative of the power here. So I get negative 1 times by e to the minus x. So now let's look at that formula again for the integration by part. So the integral of u times v dash becomes u times v, the original two functions, minus the integral of the opposite pairing here. So we've got u dash v with respect to x. So now if I were to simplify this integral here, then first up I multiply my u and v terms, which are these two here. So let's put the negative in front of the x with the e, the minus x. Subtract the integral of, now it's u dash times v, and the way I've set it up, I have the product of these two terms here. So 1 times by negative e to the minus x. Let's put the negative out in the front here. So e to the minus x times by the 1, the x. So the first pair of terms, I don't need to do anything to that. But now if I were to integrate e to the minus x, it becomes e to the minus x divided by negative 1. And now we throw in that constant of plus c. All right, next one. So let u equal the one that becomes simpler when you differentiate, and that would be let u equal x. So u dash is equal to 1, and my value of v, if I integrate cos, I end up with the sine. So now this expression becomes u times v, so this pair here, so we've got x times by the sine of x. Take away the integral of this pair here, so u dash times in v, so 1 times in by sine x, which is just sine x. The first term is left as is. If I integrate sine, I get negative cos, and I've got my constant of c. Right. Next problem, once again, let u equal, well, if I let u equal e to the x, it becomes e to the x if I differentiate. If u equals sine of x, it becomes minus cos x. So it's not any simpler. So in this case, let's let our u value equal e to the x. So u dash e to the x, and v is minus cos of x. So if we were to integrate, we'd have u times in v first up. So let's go for the negative out in front. I've got e to the x times cos of x. So here's my u and here's my v. Subtract the integral of u dash times in by v. Put the negative out in front of the integral, and let's put the e to the x in front of the cos of x. So this here looks like it is the same as this more or less, so I'm going to need to do integration by parts on this term as well. So for this pair here, I can't use u and v again, let's use say m and n. So let m equal e to the x, and therefore n dash is cos of x. So m dash, if we differentiate e to the x, we get e to the x. If I were to integrate cos, I end up with sine. So this expression here becomes m times n, so e to the x times by the sine of x, minus the integral of m dash n, so that's e to the x sine of x. So let's remove those brackets. So negative e to the x first up, cos x, plus e to the x sine x, then minus the integral of e to the x sine x dx. Now we have, that was the question, and I've got that turning up again there. So if I were to try to integrate that by parts, I'm going to repeat this whole process again. What I can do is, I have an equation here. So this term here is actually equal to that term, which is what I've written down here. So that equation there, I can move this term across to the right hand side to get two lots of e to the x sine x dx, and then I can divide the two across to the right hand side. Don't forget to throw in your constant of c, which gives us the solution.